Hey guys, this is Miss Regine from SOAR Educational Services, and today we are going to be learning about special right triangles. This is something that you will begin to be exposed to in geometry. So when you have a 30, 60, 90 triangle, and well, as you can see here, I have 60 written, but you don't see the 30 here. But I already know that there is a 30 there because the angles of a triangle, all triangles have to add up to 180. So if I have 90 plus 60, that's 150. And so now I know there is a 30 there. And it's a common triangle that has all the legs of that triangle has a special relationship that can help you solve for any given leg proportionally. So in a 30, 60, 90 triangle, if the leg across from the 30 degrees is 1, then the one across from the 90 degrees will be 2. And the one across from the 60 degrees will be radical 3. So in this given problem, we have the leg that's across from the 90 degree. That's called the hypotenuse. It is 2. It's 14. So we can create a ratio from this. So if I'm trying to find the leg that's across from the 30, so that would be this side right here. When I say across from the 30, this side right here, let me highlight it in blue so you can see. I'm looking for this leg across from the 30. I can create a proportion. Now this one I could probably solve mentally, but just so we can go through the process, we'll create a proportion. So we could do 30 over 90. So when the leg of the 30-degree triangle is 1, the leg of the 90-degree triangle is 2. In our given problem, the leg of the 90-degree across from the 90 is 14. What is the leg across from the 30? So if we have something set up like this, we can cross multiply. 1 times 14 is 14. 2 times x is 2x. Divide by 2, and we get x equals 7. So this leg is 7. And you should have been able to see that if this is 14, the one across from the 30 is just half of it. So that is 7. Now, when the one across the 30 is 1, the one across from the 60 is radical 3. So that's right here. It's across from the 60-degree angle. It's radical 3. Again, we can set up another proportion. So now if we just focus on our 30 and our 60 for the relationship. So the rule is when the one across from the 30 is 1, the one across from the 60 is radical 3. In this case, the one across from the 30 is 7. What is the one across from the 60? All right, we're going to cross multiply. 1 times x is just x because we usually don't write 1 in algebra. And 7 times radical 3 is 7 radical 3. And we will just leave it like this. That's the best answer. That's the exact answer, 7 radical 3. So as you can see, if you have this number to find the one across from the 60, all you have to do is multiply by radical 3. All right, let's try another one. This one is the 45, 45, 90 triangle. So that has a slightly different rule, but similar idea. Okay, so this is a right triangle, and we know it's a 45, 45, 90 because if this is 90, this is 45, that's 135. We need to have another 45. Sometimes they won't even write the degree. They might just put a marking or tell you it's an isosceles triangle. If they tell you it's an isosceles triangle, then that means the two angles are 45, 45. So just something to be aware of. Now in a 45, 45, 90, if the angles are the same, then the legs are also the same. So the standard ratio is the leg across from the 45 is 1, and that means the other one is 1 because it's an isosceles triangle, and the one across from the 90 is radical 2, square root of 2. So in this particular problem, let's say we're solving for x, but once we find x, we're going to find y because they're isosceles triangle. So we're looking for this. Our ratio is, if we have a 45 to 90, it's 1 over radical 2. In this particular problem, the one across from the 90 is 10. What is the one across from the 45? So you can cross multiply. I'll just write it over here for space. So 1 times 10 is 10. Cross multiply. And x times square root of 2 is x square root of 2. We have our variable x that we're solving for that's attached to something. We need to get rid of that. So we want to isolate our x by dividing by the square root of 2. Divide by the square root of 2. So we have 10 square root of 2. This is technically the answer, but in algebra, you need to rationalize your denominator. You're not allowed to have square root in your denominator. So we have 10 square root of 2. The way to rationalize your denominator is to multiply top and bottom by the square root of 2. So 10 times square root of 2 is 10 square root of 2. Square root of 2 times 2, you can plug this into a calculator, but it's just 2. And when you have a number outside, you can actually, like you have two numbers outside, one on top, one on the bottom, you can divide those. 10 divided by 2 is 5. You cannot divide it with the square root of 2. The square root of 2 is kind of like a protected space, so we're not going to just break into it. So the answer is 5 square root of 2. So if this is 10, this is 5 square root of 2. It may not be what you would have thought, like, maybe just by using mental math, you may not have realized that's what it would be. But when this is 10, the other two legs are 5 square root of 2. Okay, let me try to give you something that's a little bit more challenging. And if you think you've gotten the hang of it, you can pause the video and try it on your own first after I get it up. So let's say you have a square with a diagonal of 17, and you have these markings right here. So there's a square, so right angles here. So they want you to find the legs. X right here and Y. So what would you need to do? Well, what we would need to do is realize that, okay, well, the marking here, they're actually telling me that with this marking that these two sides are the same. So that means this would be a 45 degree and this would be a 45 degree. So really I'm looking for X and X, because that's what that marking is telling me, that this is isosceles. So we're looking for a 45, 45, 90 again. So remember that rule. I'll write it again. Again, you can pause the video if you think you have it. So in this case, the one across from the 90 is 17. And I want to find any of the leg, either of the leg. They're going to be the same. So again, we have a 45 and 90 ratio, which is a 1 to square root of 2 ratio. If we know that the one across from the 90 is 17, and it is across from the 90, it's our hypotenuse. If you imagine that you cut this square in half, we have a triangle on the bottom, that's our hypotenuse. And we're looking for this right here. Cross multiply. Cross multiply. So we have x square root of 2. Again, we need to isolate our variables, so divide by square root of 2. Divide by square root of 2. So we have 17 over square root of 2. But we need to rationalize our denominator. So in rationalizing our denominator, we have square root of 2, square root of 2. That's how you rationalize your denominator. So that gives us 17 square root of 2 over 2. In this case, I would not divide, because 17 and 2 do not divide evenly. If you're going to get a decimal answer, it's best to just leave it as the fraction. So that's our side of our triangle. All right, I will give you guys one last one. Again, a little bit more complicated. So we have a triangle here, and what we have is this is 12, this is 60, and we are looking for this whole thing right here and also right here. So in this case, we really are looking for X and Y because they're not the same thing. But what we need to know is that if we do have two triangles here, one on the left, one on the right. So let's just focus on one, but whatever we get on the left is going to be what also goes on the right. So this is a right. If you have an altitude drop down in the middle of a triangle, and they did give you, in this problem, they did give you that this is a right angle. So don't just assume, but this is a right angle. So it is actually a perpendicular bisector. It is breaking it up into, it would have been a equilateral triangle, but this is being broken up into 30 and 30, which is 60. So we also know this is 60. We didn't have to solve for all this, but it would have been a 60, 60, 60, but it just got divided. So now that we have that, and the reason we know that it was divided is the legs are right here are equilateral. There was marking from the book that has that these were equal to each other. So then you know that this would be 60 and 60 on each side. All right, so now we know we're at we have a 30, 60, 90 triangle. So remember our rule for 30, 60, 90, when this is 1, this is 2, and this is square root of 3. Now this time they have given me the leg that's actually across from the 60. So we got to pay close attention. This is across from the 60. Just look and see where it is like exactly across from, and that's across from the 60. So the leg across from the 60 is 12, and it doesn't matter which one we're going to solve. But let's solve for y, which is the one across from the 90. Okay, so if we're solving for the one across from the 90, we're going to do our 60-90 ratio. So when we have radical 3, we have 2. In this case, we have y is what we're looking for, and we're given the one across from the 60 is 12. We're going to cross multiply. Our variable y needs to be isolated so we can solve for it. So divide by square root of 3, divide by square root of 3. So we have 24 over square root of 3, but we need to rationalize our denominator. So 24 times square root of 3 is 24 square root of 3. Square root of 3 times 3 is 3. If we have 24 over 3, that is going to be, we can remember I said we could divide that. 24 divided by 3 is going to be 8 square root of 3. So this right here is 8 square root of 3. Now, over here, the quick way to know this is that it's half. But what is half of 8 square root of 3? All right, so, but we'll do our proportion. So remember our 30 and our 90, the relationship when this is 1, this is 2, so it's 1/2. We're looking for the 30. So we're actually looking for this leg right here. Let me do, highlight it in black. Just this half right here. So that's 30. And we have 8 square root of 3. So this will be an interesting relationship once you see it. So 8 square root of 3. And if you already see it, great. Because I did say you can pause the video and see if you can solve it on your own first. All right, equals 2x. Divide by 2. Divide by 2. 8 divided by 2 is 4. So we have 4 square root of 3. But actually, this problem was not asking us just to solve for the 30. It's actually asking us to solve for the whole bottom. So if this is 4 square root of 3, on this side is also 4 square root of 3. So for this problem, x equals 8 square root of 3, and y equals 8 square root of 3 for this particular problem. Now, if it was just the leg that they were asking us to solve, just that 30-degree leg, it would be 4 square root of 3. But they wanted that whole bottom base area. So that's going to be 8 square root of 3. All right, I know this was a long one. Thank you for sticking with me. And I hope this was helpful. Remember to like and subscribe, and see you next time. Bye.